Hi students. In this lecture, I am going to discuss problems based on instantaneous axis of rotation. Let us see first one. See the question given. A disk of radius 20 centimeter is rolling with a slipping on a flat horizontal surface. At a certain instant, the velocity of its center is 4 meter per second and its angular velocity is 10 radian per second. The lowest contact point is O. This is diagram. Velocity of point O is. So this we can say directly. Because of a translation, for each and every point, velocity will be 4. Okay. So it is given for center, velocity 4 meter per second. So because of translation, for each and every point in this body, velocity will be 4. And that is right side. Now, because of rotation, this point follows now circular path because of rotation. So because of rotation for point O, velocity is left side, which is equal to R into omega. R value, it is 20 centimeter. So converting into meters, it is 0.2. So 0.2 into 10, that is 2. So 2 meter per second left side because of rotation. 4 meter per second right side because of translation. So net value 4 minus 2, it is 2. It is 2 meter per second right side. Okay. So it is very simple one. See next one. Instantaneous center of the rotation of disk is located at. So we have to find about which axis. This disk is in pure rotation. Okay. Let us make a diagram. Right. See the diagram given. So velocity is given, that is 4 meter per second right side, and omega is given, it is 10 radian per second. Okay. This is now point or contact point, and there is one more point at same height as center of that disk, that is a point P. Okay. Now see what we have to find. So we have to find location of the instantaneous axis of rotation. That means about to which point this body is now in pure rotation. Then see what we can say here. This has velocity 4. Okay. For example, that point is now somewhere at some distance. So I'm taking here. It is at some distance. It is now somewhere here. This is now instantaneous axis of rotation. Then see carefully. Radius is given 20 centimeter, which is equal to 0.2 meter. Suppose now this total distance equal to x. Or let us take from here, it is equal to x. And this is now 0.2. Okay. If this is a center, velocity equal to r into omega. R means distance from the center. That is 4 equal to x plus r. Distance from the center, okay, into omega. Omega is now 10. Now see what is the value of x. 4 by 10, 0.4. 0.4 minus 0.2. X is now 0. That means the instantaneous axis of rotation is at a distance 0.2 from point O. It is below point O. Okay. I told you earlier how to identify points on the axis of rotation having zero velocity. Okay. So for this point, velocity is 0. Then this is now V equal to distance from that center into omega. Okay. So 0.2 below point O. Right. And the previous what we have discussed for point O velocity. For point O velocity, because of translation, 4 meter per second right side. Because of rotation, it is 0.2 into 10 r omega. This is left side. So net value is now 4 minus 2. That is 2 meter per second right side. This is a 4. This is a 2. In the last lecture, I have discussed that if we know velocities for 2 points and if directions are same, then that center will be outside those 2 points, right? And one more point I have discussed that will be closer to the one which has less speed. So this must be closer to point O, right? Because when I am saying outside these 2 points, you may think like it is above this center. Then one more condition is that it is closer to the point which has less speed. That's why it must be below point O. Okay. So I hope you got the clarity. And let us in next one. Next one, we have to find velocity of point P, right? Next question, velocity of point P. See what we can do. We can find this velocity in two ways. One is by using the concept of instantaneous axis of rotation. Second one, it is a combination of translation and rotation. I will discuss both here. Let us take first of all combination of translation and rotation. For point P, because of a translation velocity, 4 meter per second. For any point, velocity is 4 meter per second because of translation. Because of rotation, for this point, velocity is now, it is upwards, right? Which is equal to r omega. R omega value how much? R value 0.2, omega value 10. This is 2 meter per second. Between these two angles 90. Resultant of these two gives us velocity of point P. Or if you want to speed, take modulus of that. So velocity of point P is square root of 4 square plus 2 square. That is root 20. 20 means 4 fives. This is 2 root 5 meter per second. This is one way of solving the problem. And just now we have solved, just now we got the location of instantaneous axis of rotation, that is C. Distance equal to 0.2. Now focus distance of point P from C. See carefully. This is a point P. This is now center. And this is now instantaneous axis of rotation. Now see carefully. This is 0.2. This is 0.4. Okay. This length. Now distance of P from this point, that is now see how much? Square root of sum of the squares, right? Then see what we get. Square root of sum of the squares. That distance is equal to See that value how much? Square root of same thing, right? 4 square, 2 square, root 20. And I can take here 10 power minus 1. Here also 10 power minus 1, taking outside. This is now root 20 upon 10. Cross check once. 2 10 power minus 1. 4 10 power minus 1. I am taking 10 power minus 1 outside. Remaining is now 4 square plus 2 square. Right? It is 4 square plus 2 square. That is now root 20 upon 10. This is now distance. About this point, this body is in pure rotation. So velocity will be normal to the line joining PC. Velocity will be like this. Normal to PC. And that is equal to this distance into omega. And omega value how much? It is 10. So into 10. 10 gets cancelled. So velocity equal root 20. So we got same. Okay. So either we can solve directly as a combination of translation and rotation. Otherwise, by using this instantaneous axis of rotation, then body is in pure rotation. Then velocity equal to this distance into omega. Omega same, 10 only. Okay. So I hope you got a clarity. Let us go for next question. So answer is 2 root 5, right? Option B. Right. See the next problem. A rod of length 2 meter is kept vertical inside a smooth spherical shell of radius 2 meter. The rod starts slipping inside the shell. Mass of the rod is 4 kg. Rod length is 2, radius is 2, mass is 4 kg. Angular speed of the rod in radian per second in the position when it becomes horizontal is. Next, velocity of center of the rod at this instant is approximately. Let us focus now these two. How to calculate. Given spherical shell, radius is 2 meter. Now inside that we are keeping a rod whose length is 2 meter. Keeping a rod whose length is 2 meter. Given it is vertical. This is now rod. Okay. It is kept vertical. Now when it becomes horizontal. So finally what happens here? It becomes horizontal. So when this rod becomes horizontal, what is angular velocity? Now see what I am saying here. Since there is no friction, we can write conservation of mechanical energy. If you observe from this point, initially center of mass was at a height of, if I am taking now this as reference level, we can see from here, rod becomes finally horizontal, center of mass was at a height of, see how to find this height, or you can say this length how much, radius is 2 meter. This is now 1 meter. Then we can find now this length. I'm taking this as C. This is AC value 2. I'm taking midpoint as B. Okay. So what is BC value? So BC length will be, this is 1, this is a 2. 4 minus 1, 3. This is now root 3. So BC length is root 3 meter. Okay. Right. Now this point B comes to here. That means now this is A and this is B. right? When rod becomes horizontal. Now here what I am saying is about point C, this body is in pure rotation. I am repeating about point C, this rod is in pure rotation. See how we are getting this conclusion. Velocity for point A, it will be along the tangent, means like this. Velocity for this end along the tangent, it is like this. If you draw normals for these velocities, they intersect at the center, right? In the last lecture, I have discussed that there are three possibilities. Velocity is parallel, velocity is anti-parallel, velocity is neither parallel nor anti-parallel. In that case, we draw normals for velocities. Then point of intersection gives that axis of rotation. So about this point, rod is in pure rotation. Okay. So initially center of mass was at a height of root 3. This height is equal to root 3. That means it has lost gravitational potential energy. That loss converts into kinetic energy because of rotation. So I'm writing loss in gravitational potential energy, mgh, is converting into kinetic energy because of rotation. Then see mass is when 4 kg, g value 10, height is now root mgh. This is now loss in gravitational potential energy. This loss converts into rotational kinetic energy, half. Now you should be very careful. We have to find I value about same axis. If you take this board plane as xy plane, this is now z axis. Okay. So about this axis, I value ml square by 12. But we have to find about this axis plus m into square of the distance m into root 3 whole square. That is I value. See once answer how much? Mass 4 kg, L square, that is 2 square upon 12 plus mass 4. This is now 3. 4 here 3 times. This is a 4 by 3 plus 12. 3 12 36. 36 plus 4 40. 40 by 3. Okay. So it is now I value 40 upon 3. Omega square. Omega we have to calculate. Right. 40 gets cancelled. Omega square. So omega square. Omega value. Omega square how much? 6 root 3. Omega square. From that omega value will be approximately, it is 3.2 radian per second, right? Now in the next question, we have to find velocity of center of the rod. Okay, that means velocity of point B. And we are knowing that rod is in pure rotation. Therefore, velocity equal to r omega. R means this distance how much? From center means from the center of rotation, center of axis. Distance equal to root 3. R omega. Omega value 3.2. And this is approximately 5.5. Okay. So how we are applying the concept, that is what we have to focus. It is in pure rotation about point C. Then we have taken conservation of mechanical energy. Okay. Let us see next one. Let's see the question given. In the figure shown, F is 10, R value 1, mass of the body 2 kg, and moment of inertia of the body about an axis passing through O and perpendicular to the plane of the body is 4 kg meter square. Right? Now see what we have to calculate. If ground is smooth, if ground is smooth, what is the total kinetic energy of the body at t equal to 2 seconds? That means we have to take these forces are applied when t equal to 0. Okay. Then question is when t equal 2 seconds. Ground smooth. Ground smooth. Its meaning is, see what is a possibility? F and F. Net force 0. Ground is smooth, no friction. Net force 0 means center does not move. Means now having only rotation. That means now kinetic energy will be only because of rotation. This is what we have to understand before starting the problem. Okay. I am repeating. Net force 0 because smooth. Therefore, center of mass does not move. That means because of these forces, there is a torque. Means body is having only rotation. That means in the first case, kinetic energy is only because of rotation. That means we have to find out half 5 omega square. Okay. Let us make a diagram. Given force F and this also F R and this is 2R, right? F value 10. So 10 torque because of this 10 into R, because of this 10 into 2R, right? So F into R, F into 2R, net value F into R, net value F into R. Because of this force, torque is now clockwise. Because of this force, torque is anti-clockwise. So net value, this is F into R, this is F into 2R. Net value F into R. F value is a 10, R value is 1. This is equal to I into alpha. And I value how much given? It is a 4. 4 alpha. So alpha equal to 2.5 radian per second square. After 2 seconds, omega equal to alpha into t because alpha is a constant. Means omega value 5 radian per second, right? Omega equal to alpha t. So here what I'm writing, omega 2 equal to omega 1 plus alpha t. Omega 1 is 0. Now kinetic energy will be half I value for omega square 5 square. That is now kinetic energy. So here 2 times 225. So it is a 15. Right? So it is a very simple and direct. Okay. Now see what is the next problem. So coming to next one, it is given friction is there, right? So when friction is there, then see what happens. Because of friction, now there is a torque, right? About center of mass. That means F and F both are cancelled, right? F and F both are cancelled. But now frictional force becomes net force. I am repeating. Frictional force becomes now net force. That means because of frictional force, what happens is the system is having translatory motion along with rotation. Okay. So now what I'm saying is, let us consider since condition is given that it is a rolling without slipping. For bottommost point, velocity must be 0. Now this point becomes instantaneous axis of rotation. If you take about this point, body is in pure rotation. Okay. Then about this point, because of friction, torque will be 0. Now, because of this applied force, about this point P. Because of this force, torque will be about this point. Torque is clockwise, right? And because of this force, about this point, anti-clockwise. See what is now net torque. Net torque equal to about this point means distance from here to up to here. This is a 2R and this is R. Total is 3R. And this total value is 4R. Total how much? 4R. So 3R and 4R. So net value F into R. So how we got this? F into 4R. F into 4R minus F into 3R. Okay. Net value is F into R. So how much it is? Again 10 into 1. That is a 10. Right? 10 Newton meter. Now calculate what is alpha. Okay. Now we can calculate what is alpha. I can calculate like this without calculating alpha. Initially, this body was at rest, not rotating. Because of this torque, since which is a constant, if I am taking torque into time interval delta t, this gives us change in angular momentum. That is equal to final value minus initial value. Right? So we have discussed that, and I'm writing here. Net torque is equal to dl bar by dt, net torque. From this, net torque into dt gives us change in angular momentum. That is what I have taken here. Net torque into dt. That is equal to change in angular momentum. Initially L was 0. Now it is non-zero. So this value how much? Torque is 10 times 2 seconds. That means L value 20. Right? L is 20. Now we are knowing that the kinetic energy equal to L square by 2I. Right? And remember students, you should be very careful here because we are taking rotation about this contact point. So find I value about same axis. So I'm writing here I value, I equal to about its own axis, that is given 4 plus m into r square. Distance from here, how much? 2r. R value 1. This is 2. mr square. Okay. This is 2, 4, 8. 8 plus 4, 12. This is 12. 12 kg meter square. So L square, 20 square by 2I, 2 into 12. Okay. Then see calculation 2. 10 times 2. 5 times and here 6 times. 100 by 6. Approximately 16.67, right? Approximately. Okay. That means if we are taking about this contact point, calculation becomes more simple. If you observe, if we are not taking like this, then how to solve it? Then we have to find out what is omega when t equal to 2 seconds. Next, what is BCM when t equal to 2 seconds? Then we have to find half m BCM square plus half I omega squared. Okay. So this is more simple when compared to that method, right? So first one 50 joules, second one 16.67. So options are for the first one 50, second one 16.67. Okay. So I hope you got a clarity how we are taking the concept of instantaneous axis of rotation, right?